In this lesson, we're going to be looking at the unit circle and trig functions. So to remind us about trig functions, let's look at trig functions from right triangles. So let theta be an acute angle of a right triangle. Then the 6 trig functions of the angle theta are defined as follows. And then note that the functions in the second column right here are just the reciprocals of the corresponding functions in the first column. And as a reminder, if you want to remember SOHCAHTOA, where sine is the opposite over hypotenuse sides of a triangle, and then the cosine is the adjacent side over the hypotenuse in a right triangle, and then the tangent is the opposite over adjacent. If you can remember these 3 trig functions right here, then all you have to remember is that cosecant is the reciprocal of sine, and that would be hypotenuse over opposite side. If you can remember that secant is the reciprocal of cosine, so we just flip these 2 sides, hypotenuse over adjacent, and that cotangent is the reciprocal of tangent, where we just flip, reciprocate opposite over adjacent to adjacent over opposite. Okay, well, how are these similar yet different for the unit circle? So let's look at the unit circle definitions of trig functions. So we have the same 6 trig functions down here. So theta is an acute angle in a unit circle's right triangle. So hopefully you have your unit circle that we completed in the last video handy, because we're going to reference that. Then the 6 trig functions of the angle theta are defined as follows, and this statement is the same as the previous statement. Okay, so sine of theta in a right triangle is opposite over hypotenuse. So let's look and see what that looks like on the unit circle. So putting that back in front of us. So let's first of all just look at this right triangle that we formed in a previous lesson. So if I drop that altitude down and create this right triangle, remember this is 30 degrees, this angle 60 degrees. So the sine of 30 degrees, sine is opposite over hypotenuse. So when we look at the opposite side right here, instead of calling it opposite, I'm going to call this the vertical component y. This is the distance up to that point on the unit circle. This is the y coordinate of this ordered pair. So it might serve you well if you just put y above the half. Okay, so then you might remember that across from the 60-degree angle, we have square root of 3 over 2. Well, we're going to call this distance from the origin over here to just right underneath this point, we're going to call it the x-coordinate. So that's the x-coordinate of this point right here. So instead of saying opposite over hypotenuse for sine of 30 degrees, I'm going to call this r. It is this distance from here to here is the hypotenuse of this right triangle, but when we place this right triangle on a unit circle, we can now instead call it the radius. So instead of saying opposite over hypotenuse, we're now going to use the coordinates y, or at least the coordinate y, and the radius r. So we'll say y over r. So let's come back here to this worksheet and say, okay, sine of theta on a unit circle is going to be the y coordinate divided by the radius. And when we're on a unit circle, we know the radius is 1, so we can just simply say that sine of theta is the y coordinate as long as we're on that unit circle. If our radius isn't 1, then I can't just say it's y, sine of theta is y. I'd have to say it's y over whatever the radius of that circle would be. Okay, let's find the cosine of theta from the unit circle. So the cosine of theta, okay, we knew it to be adjacent over hypotenuse in a right triangle. Well, we have a right triangle. So at 30 degrees, the adjacent is x, or this coordinate, over the value of the radius, which is just 1 here. So, but we're still going to set up the fraction adjacent over hypotenuse, or x over r. So you might remember in a right triangle, the tangent is opposite over adjacent. Well, we have a right triangle, it's just on the unit circle. Opposite, adjacent, we would say that it's the y coordinate divided by the x coordinate. So we have y over x. No hypotenuse in tangent, it's just opposite over adjacent, or in this case, it's the y component over the x component. So, and then these would be easy to fill in because remember, they're just reciprocals. So cosecant of theta is the reciprocal of sine theta. So this would be the radius over the y coordinate. Likewise here, it's r over x, and likewise the cotangent would be the x coordinate divided by the y-coordinate. All right, so our objective in this lesson is to find the exact values of the 6 trigonometric functions for each given angle. So for our first example here, we've got theta is equal to pi over 6. So I'm going to come over here to my unit circle and I'm going to locate pi over 6. Well, pi over 6 is equivalent to 30 degrees, so I'm talking about this right triangle right here. So we want to find all 6 trig functions at theta equals pi over 6, or 30 degrees if you want to think about that. All right, so let's come down here. Sine of theta, but in this case, theta is pi over 6. All right, I'm on the unit circle because pi over 6 is an angle on the unit circle. So I'm going, what is the sign again? Yeah, opposite over hypotenuse, but it's really the y-coordinate divided by the radius length. So for me, I'm going to come over here. I'm going to go, the sine at pi over 6 is y over 1. Y over 1, because radius is 1. So 1/2 over 1 is just going to be 1/2. Not that I would have to write this right here. I could directly go to just the y-coordinate of 1/2 since my radius is 1. What's the cosine of pi over 6? Well, cosine is adjacent over hypotenuse, but it's really going to be the x-coordinate over the radius. So go back to your unit circle. We're pi over 6. That's the triangle we're in. The x-coordinate, square root of 3 over 2 over 1. So our cosine of pi over 6 is just square root of 3 over 2. All right, let's get to the tangent next. All right, tangent is y over x, or opposite over adjacent. So we come up here and we look at our coordinates, y-coordinate over the x-coordinate. So 1/2 divided by square root of 3 over 2. So 1/2 divided by square root of 3 over 2. But instead of dividing by square root of 3 over 2, I'm going to multiply by the reciprocal. So really what I'm doing is I'm looking at 1/2 and I'm going to attach a multiplication sign behind it, and then I'm going to reciprocate square root of 3 over 2. Because I don't want to divide these two fractions. So 1/2 times 2 over the square root of 3. So we have a little bit of work to do here. So the 2's will divide out, and we're left with 1 over the square root of 3. And that's a fine answer, but let's rationalize it. So to get the square root out of the denominator, let's multiply by the form of 1, square root of 3 over square root of 3. So the tops multiply, give me square root of 3. Square root of 9 is just 3 down here. All right, now I'm going to find the reciprocals. So cosecant of pi over 6, secant of pi over 6. My hole punch here is in the way. And then cotangent of pi over 6. All right, cosecant of pi over 6 is just the radius over the y-coordinate. Well, I know the radius is 1. And what was the y-coordinate? Well, it was 1/2. So basically what we're doing is we're just reciprocating this value here. So let's just flip 1/2 and get 2. And we're done. All right, what's the secant of pi over 6? Well, because I know the cosine of pi over 6, and I know cosine and secant are reciprocals, let's just take this answer and reciprocate it. Flip it. Now we don't want to leave that square root in the denominator, so again, remember we're rationalizing. So we end up with 2 square root of 3 over square root of 9, or just simply 3. All right, the cotangent of pi over 6. Well, we know cotangent is x over y, so I could go back here and take x and divide it by 1/2, or multiply by 2 over 1. But instead of doing all that work, because we've already done the tangent work, we can actually just take this tangent answer and reciprocate it. Well, think about if we were to reciprocate this form of the answer, that's going to put the square root of 3 in the denominator. I'm going to have to rationalize again. So before we had square root of 3 over 3, remember back over here, we had 1 over square root of 3. So why don't we just take this answer, 1 over the square root of 3, and reciprocate it, which means we're going to have square root of 3 over 1, and then we don't even need the divide by 1, and we don't need to rationalize, so we're finished. All right, let's look at another example. Let's find the 6 trig functions of pi over 4. All right, sine of pi over 4 on the unit circle. Pi over 4 is on the unit circle, so I'm coming over here going, okay, Sine of pi over 4 is going to be the y-coordinate divided by the radius, which is 1. So let's go to pi over 4. Well, pi over 4 is 45 degrees. It's right here in yellow. So I can make that triangle if I wanted to, but I'm trying to go with the formulas. So the sine is going to be the y-coordinate. The y-coordinate is square root of 2 over 2, as is the x. So I'm going to take square root of 2 over 2 and divide it by the radius length of 1. So in this case, that's just going to be square root of 2 over 2. All right, what's the cosine of pi over 4? Well, that's x over r. Well, the x-coordinate is the same as the y-coordinate, and the radius is 1, so we just also get square root of 2 over 2. So what's the tangent of pi over 4? Well, that's your y-coordinate divided by your x-coordinate. Well, what's square root of 2 over 2 divided by itself? Well, when you divide these two numbers and they're the same, you're going to get just 1. All right, let's set up the reciprocals. Make sure you're putting the angle after the trig function. You wouldn't want to just leave that blank there. All right, cosecant of pi over 4. Again, it's just the reciprocal of the sine. So why don't I just go back up to sine and take this answer and reciprocate it? 2 over the square root of 2. Oh, but we got a little work to do. We got to get the square root out of the denominator. So in the top, I end up with 2 times the square root of 2. Square root of 4 is just 2. I wouldn't want to leave these here unsimplified, so divide those out. Final answer is just square root of 2. All right, what's the secant of pi over 4? Well, let's go back to the reciprocal of secant, which is cosine. Let's reciprocate, get 2 over the square root of 2, but we got the same thing we did for cosecant of pi over 4, so I believe that answer is going to be the same. All right, cotangent of pi over 4. So that's x over y. So again, x and y are the same number. Divide them, you're going to get 1. Or another way to think about it is go back to tangent, just take that answer, make it a fraction by putting it over 1, flip it. You're still going to get 1 over 1, so that answer is also 1. All right, let's find the 6 trig functions at negative pi over 3. So sine of negative pi over 3. Some might put parentheses right here, so it doesn't look like it's sine minus pi over 3, which wouldn't make sense because sine doesn't have an angle after it anyway. So if I have sine here, I've got to have an angle after it. So hopefully we won't mistake that negative as a subtraction. All right, you can put parentheses or not, doesn't matter. So sine of negative pi over 3. All right, so let's go to the unit circle. Remember, it's y over r. Well, negative pi over 3 is actually coming down this way. This is 1 pi over 6 section. This is 2 pi over 6 sections. That makes pi over 3 in a negative direction. So we can say that 5 pi over 3 is coterminal with negative pi over 3. So what we want to look at are the coordinates right here at this point on the circumference of this circle. So remember, this is x and this is y, and again, we know the radius is 1. So without drawing the right triangle, and I could by drawing up this way to the positive x-axis, putting the right angle here, okay, and this would be negative pi over 3 as an angle. Instead of drawing all that, let's just focus on using these coordinates and the formulas we have. Okay, so here are our coordinates. So I might actually come over here so I don't have to keep going back and forth and record the coordinates at that point. So that's 1/2 negative square root of 3 over 2. And I might label this x and y, and I do know r is 1. What's the sine? Well, it's y over 1. So it's negative square root of 3 over 2. We're done. What's the cosine at negative pi over 3? Again, cosine is x over r. Here's the x-coordinate. Radius is 1, so we just get 1/2. What's the tangent at negative pi over 3? Well, it's y divided by x. This tangent is y divided by x. So it's going to start with the y-coordinate, record it first. I don't want to do a division. I'm going to change to multiplication, and I'm going to multiply by the reciprocal of the x-coordinate. Divide out the 2's. My answer is negative square root of 3. All right, let's find the 3 reciprocals. So cosecant negative pi over 3, etc. All right, what's the cosecant? Well, its reciprocal is sine. So if I look back up here, if I reciprocated that, I'm going to get negative 2 over the square root of 3. It doesn't matter where the negative goes, if it goes up top, down at the bottom of the fraction, or out in front. Well, I want to rationalize, so I'm going to multiply by square root of 3 over square root of 3, but we already did that work. We did that work way over here. In this first example, when we rationalized, we ended up with this nice answer. But remember, over here in our problem, we have a negative value. So I'm going to say this is equal to negative 2 square root of 3 over 3. Secant of negative pi over 3. Secant, as you might recall, is the reciprocal of cosine. So this answer is 1/2. Let's reciprocate it, make it 2 over 1, but we would just record the 2. All right, cotangent of negative pi over 3. Well, here's the answer for cotangent, or excuse me, for tangent. So if we thought about putting that over 1, then cotangent would be negative 1 over the square root of 3. Again, we have a radical in the denominator. I think we've done this work somewhere before. Back here in this first example, when we had 1 over the square root of 3, when we rationalized, we ended up with square root of 3 over 3. But remember, this is negative, so we have to reattach that negative here. All right? So in this lesson, we use the unit circle to find the 6 trig functions at various given angles.